Okay, so the next important thing is in the byte order. How is a word stored in memory? So suppose that we have a value stored in x1. This is a 32-bit value, a 1, 2, 3, and 4 expressed in the form of hex. This is completely a 32-bit and 4 bytes. When we execute this instruction, what happens? So this is the immediate value. This is a register. Where do you think this value is going to store? Which byte will be stored at which location? Again, 100 is pointing to a memory address where the value stored in x1 should be stored. So again, we are copying the entire word, and you are just looking at memory in the form of bytes stack. Okay, so this is the first byte, the second byte, third, and fourth. So which byte 0, 1? Okay, let's only focus on 0, 1 or 0, 4. Where are they going to store? At the first location or the last location? So there are two standard representation which we commonly refer as Endianness. So if we have a situation like this, one format is called big Endian, where the big end of your data, big end means the most significant byte of your data, in this case it's 1, is stored at the lowest memory address, which means that if you were to store it in this format, big Endian, the 0, 1 will be stored at the lowest memory address, which is 100. Okay, so this is the biggest byte, most significant byte. It is going to be stored at 100, and the smallest byte will be stored at the largest memory address. This format is called big Endian, and this is again important from your exam point of view. You should be able to identify if the format of data is big Endian, so where it will be stored. The another format is called little Endian, where the lowest byte or the smallest byte, which is the least significant byte, is stored first in the lowest memory location. Okay, and RISC-V uses this little Endian format. Okay, if I were to ask you about, say, suppose we have a data, let's say 35 4F. How will it be stored in big Endian? So suppose we have a memory, and let's say this is 0x 1000, 0x 1000, and let's say this is big Endian format and this is a little Endian format. So we have to store this thing 35 4F. So this is first byte and this is another byte. So in the big Endian format, the biggest end of the data, which is the biggest, most significant byte, will be stored at the lowest memory location. So it will be stored at 35 and 4F. And little Endian format, the lowest byte will be stored first, which means 4F and 35. Okay? Yep.
Why aren't those 2 bytes though?
So it's just an example. Oh, I'm talking about in hex. So each digit corresponds to 4 bits.
Oh, okay.
This corresponds to 4 bits and this corresponds to 4 bits, so it's a 1 byte.
Yeah.
Okay. Any other question? Okay, let's go back. So let's do a quick knowledge check here. What are the bits in T0 after executing the following RISC-V instruction? So first of all, understand what does LW do. LW is loading a word from memory into register, and register is here T0. So what will be the contents of T0? Again, you are practicing your exam. We are talking about RISC-V And when we are talking about RISC-V, it means it's a little endian format. Okay, so what is the correct answer? Yep. A. So A is the correct answer. Why? Because you see, whatever is stored at the lowest memory address must belong to the least significant location. So AC, 81, 65, and 32. Okay. Any confusion? Do you want me to explain again? Sorry?
I thought you were only loading AC.
No, the entire 32 bits, like the 4 bytes, the entire word. LW loads the word. Okay, so word means 4 bytes. Okay, so let's proceed ahead.